This is a loosely coupled show with James Hickey and Comartin. If you're new to this channel, we chat about software architecture and design. Make sure to subscribe to get all our latest episodes. So, like you mentioned, Kafka and then Rabbit. Like, where's the distinction? Like, what's the use case for each?
He uses Kafka to send to Rabbit, and then Rabbit sends to another topic. And then...
you joke, but we've got a. I mean, it's primarily historical. So far, we were using Rabbit and running into various issues that they didn't have competing consumers until quite recently, and that was causing issues. We had a whole huge amount of infrastructure around trying to get some sort of the linearity process properties that you get out for free in Kafka, trying to enforce them into Rabbit before was causing us some difficulties. And so, yeah, I think generally we're just sort of transitioning most things from Rabbit to Kafka. They do feel like they're different, but I haven't really got a solid handle on exactly where one outshines the other. Like Kafka obviously has the benefits of everything is linearized, but I don't know. I'm not really sure. In honesty, like it feels like it's relatively expensive to create topics and things in Kafka, and I think that's something they've resolved now. But you had to be quite careful. Whereas it felt like we were using Rabbit with mass transit, and it felt very easy. You could just throw another event out and have somewhere to catch it. It feels like you can't be quite as haphazard as that with Kafka. But again, I'm not entirely sure, and it's
Yeah, I guess it probably depends on what people are using either each for specifically. Because when I was at a conference in the fall, I was talking to a database vendor that is, I won't give them away, or maybe I will, Event Store. And I recently wrote a blog post for them, basically because of that interaction that I had with them. And I guess the conversation I had with them is, how do you, to them, resolve the notion that they would be used for the same purpose? Because to me, something like there was a lot of things I was reading at least last year, maybe this time, about event sourcing and Kafka for event sourcing, and I don't get that at all. And then I had a conversation with Ian Cooper somewhat about this, which is there's just different, like so many things in our industry, there's so many terms that get confused or conflated that start meaning other things. So because it's ultimately a log, well, to me, I'm saying this is my opinion, it's ultimately a log, and you can view an event store like Event Store DB as a log, but how those partitions work is very different. Event Store is permanent. So yeah. I guess it depends on how you're using and like what your purpose is for something like that. If it's simply for integration between different systems where you're just, here, I'm throwing this to essentially a log and you can pick up whatever you need to do with it. Do you need permanent record of it?
Yeah, so in terms of the way we're doing it, it absolutely matches with what you're saying. It's not, Kafka isn't a permanent record. It was more the fact, I think as well, that Rabbit was absolutely not permanent. It's ephemeral. You consume it and then it's gone.
Gone, yeah. At
least with Kafka, it seems like it's sort of in between, and yep. There's a limit to how many you have in a topic. So you absolutely wouldn't want, for like you say, for the event store, I wouldn't want my event suddenly disappearing off the bottom, when it gets full. That just seems, I don't know, it's madness. But yeah, so exactly, I completely agree.
Yeah, I think it just depends what you're using it for. I don't know. I can see how people would be. I get it. I get why I could see using Kafka. It would fit my needs in a lot of circumstances for, again, just integrating between systems and using it purely as exactly that, as kind of a, I don't know what, like, what's the default retention? Like, do you have to define it? Or is it like there's something out of the box that says, hey, this is what the retention is?
I can't remember,
Yeah.
but it depends on, it depends if you're hosting your own or if you've got it set up. Services have their own
Yeah.
default retention. I mean, compacted topics are interesting as well, but they are very different as well. And those are quite interesting for the whole sort of internal data versus external data stuff that Ian Cooper's talked about quite a lot as well. And so that again is for communicating between services. That's where we use it.
So is it mostly like you're saying just the time piece? You're guaranteed of the order of events. That's really the benefit for you, or is there like performance considerations?
I mean, it's primarily partitioning, which is you can get quite nicely, and yeah, the linearity. So you just have, a small number of consumers, and I mean, it's really that. I think it's really that partitioning which gave us the thing. You can have that message key, like that entity key, essentially, so that only one consumer will be handling the messages for this process. For example, if you've got to have a saga, you know that even if you've got 8 replicas of your message handling services, but only one of them will ever be handling the messages for this one saga, which is where we were having difficulties before with Rabbit. We had to have a whole load of, we were using advisory locks and Postgres to work around that, and it was just, it sort of worked, but it was a bit messy.
Yeah.
Yeah, so that's basically with Rabbit, you might have multiple instances of a worker who's grabbing messages, and in this case you only want that let's say response to an event or to a message to happen one time, but then you basically have multiple workers who are trying to grab the same message all at the same time. So either some of them get the same message and do that same action at the same time, which is like data corruption can happen and stuff. And what you're saying, I think, is you basically have to have some kind of distributed lock somewhere that you're saying, okay, I have the lock. I'm going to grab that message and do what I need to do. I'm done. I'll release that lock. So Kafka kind of gives you that out of the box, and you don't have to worry about having multiple workers grabbing that like specific message in question.
Yeah, exactly. So if I've got it's my order with ID equals 3, I don't want replica number 1 and replica number 2 to both be trying to do something like messages with order that relate to order number 3. Yeah. I can be sure that only one of those replicas will be dealing with that particular order, and a different replica could be dealing with messages for a different order, but only one of them will be dealing with that at one time.
That's cool. See, I didn't know. So I'm not that familiar with Kafka, so I didn't realize that was something that Kafka solved, right? That's really interesting. I kind of like to ask some more questions because that's really cool because it's kind of in line with some stuff that I've been working on with distributed locks. So like, is it dynamic, or do you have to say like, I've got 5 instances, and like if I send a message to Kafka, does Kafka just automatically say, or like does it already recognize I have 5 instances who are like connected to me for this topic? I'm just gonna like auto assign this to one of them.
So when you set up the topic, you set up a number of partitions that it has. So you might have like 9 partitions, for example, and then you have consumers of that topic. And so say you've got 3 replicas, so you've got three consumers for that one topic, then Kafka will automatically assign 3 partitions to each replica. So, and it uses that to ID 3 means it only goes with partition number 3, which is assigned to replica number 1, or something like that. So each replica will only deal with a sub number of partitions. Then if you add another replica later, it rebalances all that and it handles that for you. So you can handle, essentially if you've got 9 partitions, you can handle up to 9 replicas. If you get more than that, then they won't be used because they can't split it out any more than that. But there'll only ever be one replica handling a partition at a time. But the other thing you get though as well, which you don't get with Rabbit, is you can have multiple types of consumer for a single message, which I know you can get that actually, can you? Yeah, no, forget that.
So yeah, I mean, for me, that's something I didn't know, but that sounds like quite a huge. Like I could see the benefit in that as like basically what you were saying, right? If you're using something like Rabbit and you have this message that you want to handle, but you've got like 10 instances that are available to grab that message, you basically have to grab a shared lock and grab that. And there's overhead. I mean, you think of like locking in code. There's definitely some overhead there where you're potentially blocking other workers. But yeah, with Kafka, it's very interesting. Yeah, it's kind of cool. It kind of reminds me of like in code, if you have like a list, or a diction. In this case, it would be like a concurrent dictionary where you have a bunch of different blocks or semaphores, which might be, for a particular key, you can say, give me the lock for this particular key, and I'll use that. Sounds like Kafka is really kind of doing something like that, but it's just kind of out of the box, just really cool. You can see how they would be a lot more scalable in terms of performance. You could definitely pump out a lot more messages concurrently that way. Is that kind of the same thing?
Yeah, I mean, the performance side, I don't think we've really tested a huge amount, because we've still got both in production. We're still using Rabbit. We're still using the old sort of lock style as well. We just don't. Occasionally, you get a problem where with Rabbit, where two separate replicas grab a message related to the same order, and you just don't get that with Kafka. That's the thing. You just know that you're just going to messages related to that order are always going to be grabbed by the same consumer, which just resolves that problem. Which is that's the nicest thing.
And then you don't have to write. You don't have to write all that locking stuff yourself, or you can get rid of that code if you're doing it.
Yeah, exactly.
I
mean, it's not all. It's the infrastructure side of it. Suddenly, it makes it sound really trivial, but we've still written a lot of .NET code just to manage. Retries are not easy. They've gone through several iterations of trying to get retry infrastructure in place, and the trying to handle like the outbox pattern using Kafka and things as well becomes tricky. But I mean, that's the case with a lot of things, I guess.
Yeah, that's what I was going to ask about that, but I was also going to ask like if when kind of this was introduced, instead of using Rabbit, were other things looked at, like just in terms of cloud providers, like whether Event Grid or whatever the heck it's called in Azure. I don't use Azure, so I think it's called something like that. Or even like SQS and SNS. Like if those fit the bill, I think they don't, probably because of that partitioning that you are alluding to. Like if you're partitioning something by order, I don't know how you would do that.
Yeah, honestly, I didn't do the research for it, so I'm not really sure. But from what I know of it, no, I don't. Yeah, the other thing you get nicely with the Kafka is that you is having multiple types of consumer pull into that and pick up the old data. They start from the beginning of the log and they can read, however much retention you've got, they can get up to speed basically. So we can use that for things like you can have summary data as well. If you use compacted topics, you can have it's essentially like it starts to become a bit of a distributed database. That's the only thing I start to lose sight of. Why is at some points you end up with, why is Kafka better than just having a database when you have compacted topics? And I haven't really got my head around why one is okay and one is considered horrendous.
We hope you enjoyed this episode of the Loosely Coupled Show. If you did, please subscribe for more on software architecture and design.